Today's objective will be to solve systems of linear equations graphically and algebraically. Our mathematical practices are going to be number 2, to reason abstractly and quantitatively, and number 6, attend to precision. Vocabulary. Number 1, system of equations. This is defined as 2 or more equations with the same variables. There are several different ways to solve systems of equations. Number 1 is to use a table. So in this example that I showed you in the previous scene, y1 is equal to negative 2x plus 8 and y sub 2 is equal to 4x minus 7. We can set up our table. The important part is that you can choose the x values. So once my equation is in slope-intercept form, that's y equals mx plus b. Both of these are in that correct form, so we can proceed. You can pick your x values. It's easy to start with 0 and 1, and then you might want to pick a negative number, but you can also pick 2, 3, again, whatever you feel comfortable with choosing is fine to choose your x values. Once you've chosen your x values, then you substitute those in and solve for your both equations. So if x is equal to 0, I'm going to sub that into my first equation here. Okay, so we're going to sub that in for x here and x here. And then we're going to calculate these values. So negative 2x, that's going to be 0, plus 8. So negative 2 times 0 is 0. 0 plus 8 is 8. So I get a value of 8 into that y sub 1. And then I can do the same thing for y2. 4 times 0 minus 7. So 4 times 0 is 0. 0 minus 7, negative 7. I will continue on and substitute 1 into both of these and get a value. You can put the other 2 in and complete your table. All right, example number 1. The directions say solve the system of equations by using a table. Quick note, if the directions specify the way you have to solve this system, then you must follow the directions. If it just says solve the system of equations, you are free to use whatever method we are going to learn about for you to solve that system. For this one, we're going to use a table. So here's my system, and here's my table that I've already put down on my paper. So the first thing we need to do to make this easier on ourselves to calculate our values is to put each one of these equations into slope-intercept form. So remember, slope-intercept form, y equals mx plus b. So we are going to solve these two equations for y. So we've got 3x plus 2y equals negative 2. So I have to get y by itself. So I'm going to subtract 3x. So 2y equals, I'm going to put my x term first, negative 3x minus 2. And then I simply want to divide every term by 2 to isolate the y. So my first equation is y equals negative 3/2 x minus 1, because 2 divided by 2 is 1. My next one is going to be this negative, I'm going to circle that, negative 4x plus 5y equals negative 28. So again, I'm going to solve this equation for y. So opposite of a subtraction or negative is add 4x to both sides. 5y equals, again, I'm going to put my x term first, 4x minus 28, and then I want to divide 5 by every term. So that will leave me y equals 4/5 x minus 28/5. Okay, so the important thing to know here is that, yes, you do have fractions, but that's okay, because if you use your tools wisely, you can use fractions in the calculator to help you calculate faster. So now what we're going to do is complete our table. So we want to go choose our values for x. So I'm just going to simply choose 0, 1, and 2. Okay, now, to finally answer this problem that says solve the system, when you have two ordered pair that end up the same, 2, -4, and 2, -4, we have found that both of these lines meet or intersect at the point of 2, -4. So to answer our problem, the solution to this system is 2, -4. Now I would like for you to pause the video and in your notes work on practice problem number 1. The second way to solve a system of linear equations is by graphing. And the solution to this system will be the point of intersection of those two linear equations. Please make a note that before you begin to graph equations, please put them in slope-intercept form, which is y equals mx plus b. Okay, example number 2 says, solve the system of equations by graphing. Once again, it specifies to solve by graphing, so that's how we're going to solve this system. The first thing we want to do with each equation is put it into slope-intercept form, which is y equals mx plus b. So let's do that. I'm going to subtract 2x from both sides. That leaves me -y equals, I'm going to put my x term first, -2x minus 1. I'm going to divide every term by -1 to get y to be positive. So y equals 2x, because -2 divided by -1 gives me positive 2. And then -1 divided by -1 is positive 1. That's my first equation. Second equation, going to do kind of the same thing. Solve this thing for y, so that means I first subtract that 5x. So 2y is equal to -5x minus 16, and then I'm going to divide every term by 2. That just isolates my y, leaving me the equation y equals -5 halves x minus, and then 16 divided by 2, I can change that into 8. Okay, I'm going to grab my graph, or my grid, okay, and then we're going to go ahead and graph both of these equations on the same coordinate plane. Now, to me, my first point on the graph is that +1, because that's my y-intercept. So I'm going to start at my 0, 0 coordinate and go up 1 and put a point. Okay. Now I'm going to get my next point by using this slope, okay, of +2/1. So it's positive, so I'm going to start with the point that I put on the graph already, and I'm going to go up 1, 2, and right 1. That's another point on my graph. Okay, now I'm going to do the same thing. Since I've got a slope of 2/1, I'm going to go down 2 and left 1, down 2, left 1. Just put a couple of points on this graph so I have plenty of them to see where the other one is going to intersect. Now, once I've got a nice amount of points on that graph, I'm going to draw the line to connect those dots. So that's the graph of y equals 2x plus 1. Now I'm going to do the same thing for y equals -5 halves x minus 8. So again, I start at my origin 0, 0. This is my y-intercept, so that's where I'm going to put my first point on the grid. So it's -8, so I'm going to go start on 0, 0 and drop down 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, you can see that I'm a little bit beyond, or I'm going to run out of room on my grid. Okay. So my -5 halves is my slope. All right. So instead of, I could drop down 5, 1, 2, 3, 4, 5, and come off the graph, but I can also go up 5, 1, 2, 3, 4, 5, and then right 1, 2. Oh, look, I notice that I just ran into a coordinate that was on this other graph, or this other line that I drew. So once that happens, that's the point of intersection of those two lines, so that's probably going to be the solution to my system of equations. So let's grab this coordinate. So that's going to be 1, 2. So x is -2, and then y is 1, 2, 3, -3. Okay, so let's go back. All right. That's the solution that I got based on my graph. Now the last thing we need to do is check to make sure both these coordinates are equal and fit in my original equations. This is my x value and this is my y value. So I'm going to plug them into my original equations. So 2 times x, which is -2, minus y, which is -3. Does that equal -1? Well, that's -4. This is a +3. So -4 plus 3 does check out to a -1. So that one works. Now let's try my second equation. So here we go. 2 times y, well, y is -3, plus 5 times x, which is -2. Does that equal -16? Well, let's check it. 2 times -3, that's -6. 5 times -2, that's -10. Okay, -6 minus 10, that does equal -16. Okay, so those both check out. So the solution to this system of equations is -2, -3. Pause the video, and now it's your turn to work on practice number 2. All right, now we're going to take a look at characteristics of linear systems. So a couple of vocabulary words. Number 2, consistent, having at least one solution. Then we have to look at, is it an independent consistent, which means exactly one solution, or is it dependent, which means having an infinite number of solutions? Then if it's not a consistent set of linear equations, then it's inconsistent, meaning that it has no solutions. So here's kind of a one-stop shop for characteristics of linear systems. Okay, so right now you need to stop or pause the video